Thanks. Before I start, uh, how many of you here have experience using BigQuery or any large-scale data warehouses? Raise your hand. I can see everyone. So can you guys raise your hand? Okay, I see a couple of hands here. Uh, those who haven't, BigQuery is one of the largest data warehouses out there. Competitors are Snowflake, Databricks, and whatnot. We're going to talk about remote functions today. But before we go into there, I'll just give a quick intro, which has already been given. I am Yash. I work at a consulting company called Vivanti. I specialize in cloud, data, and AI. I'm also a Google developer expert in cloud and AI. And surprisingly, I am not going to talk about AI today. Hopefully, you forgive me for not talking about AI in this era of AI. But yes, we are going to talk about data warehouses and how we can add on a few functionalities that they miss. Agenda, I'll start with a case study. We'll go with the other way around. I'll start with a sample example. I'll minify a couple of tables, and then we'll start from there. Decide why did I have to use remote functions, or why would you need to use remote functions? Going through that, we will discuss the implementation details and design considerations because, again, as all things are, there's no magic bullet. Then we'll also talk about what are the other use cases that remote functions can support. It's not just this case study, but there's so many things out there that remote functions can help with. Finally, we'll go into a little bit of action with demos, and I'll also walk you through a little bit of code. Let's start with the scenario. I have a table which most of you would have seen. You have a customer ID, you have a phone number, and you have all sorts of details about a customer. Let's call this a customer table for now. And again, I've just randomly added some values here. There's a table number 2, which is message ID, again, random numbers, and a message body. Has something in it for now, but let's say it's a JSON which has been encrypted, and the timestamp on when this message was delivered. So if I ask you which customers did get a message, how would you find that out here? Just based on these two tables, and consider both of these phone numbers and message bodies are encrypted. So the first thing that would come to mind is, let's see what the JSON has inside the message, and then there's a phone number. Let's join them together. So doing that, we decrypt the phone number, we decrypt the message body, and we come up with something like this. So the phone number is again a dummy phone number that I've added 1235 78965, random number again. And there's a message that we sent out 12345 phone number, and just added a dummy message as well, which is this is message 1. Now it seems much simpler, right? I could now just join on phone number and message body dot phone number, and I'll find out who did I send a message to, right? How many of you think that's easy? Yes, I see a few people. That's easy, right? It's just a simple join. I like it easy. But anyone who's worked in corporates know you can't keep your phone numbers lying around decrypted. Not just phone numbers, any PII would never be allowed to be decrypted sitting there on a platform for you to just go on and join and see and do whatever you want to do with it. Someone would come up with a new plan. What if, while we get the data in memory, when the data is decrypted, we hash it in a one-way hash. So one-way hash cannot be restored back, right? So we're losing that information for your phone number, but when we see that the message body, we are able to extract the phone number and the message, which gives us the same phone number. And now when we join on the phone number, we get the people who got messages. How many of you think that's easy? No, that's super easy. It's just a simple inner join, isn't it? I guess people are getting used to my gotchas. Um, Actually, it is an easy way out. And if you decrypt them like this and hash them, there's no security concern anymore. You could just go and keep using your phone numbers to join. There's no sensitive data lying around, and you're able to find what you need. It is a good solution with a small catch is you're never able to get back the phone number. But if you had customer ID, you can join it with back your customer data and you can do a lot of things with it. But while exploring this problem, I realized, is there a better way to do that? And turns out there is a way to decrypt data or actually do a lot of computation outside of your SQL engines. And there we have the solution three, which are remote functions on BigQuery. AWS has Lambda functions, Lambda UDFs, sorry, and Snowflake has external functions. And what these allow you to do is offload your process from your warehouse, let's say BigQuery or Redshift or Snowflake. You can offload that processing out of your warehouse and let an external service do the processing and just come back with results. How cool would that be, right? Going through the architecture of it, I wouldn't say architecture, just the flow diagram of it. This is what a BigQuery remote function would look like. You have some data sitting in your warehouse. You create an external connection which lets BigQuery communicate with the HTTP endpoint. It could be Cloud Function or Cloud Run, doesn't matter. You can select, and we'll talk about when to choose what. But BigQuery can now communicate with serverless compute that can do much more complex processing than what SQL would let you do, but still use SQL to govern or process your data. That sounds interesting. Isn't it? So, uh, how many of you are familiar with Python? Yay! A lot more this time. Nice. Um, so I've just written a simple Python function, and it's not like a fully finished code, but you can see what I'm doing here is I have a function that decodes a base 64 string, and for the sake of this entire demo and activity, I've just kept everything as base 64 decoded. In real life, you would have much more complex algorithms that decode encode, and mostly it's not under your control. When you get data from some sources, it's not under your control that what encryption to use. Otherwise you could have just gone around with using BigQuery's AEDT functions or other metric encryption decryption algorithms. But in reality, it's your vendor or your service provider would have a specific kind of encryption for the data. You just have to live with it. So you could just write a decryption function here using your keys, which can sit in its own compute. That's about what you can do. So it can be anything here. It just needs an input as a message, and you just need to respond back with something. And the other function that you see here is just a accepting request function. So what it does is it takes a Flask HTTP request, processes it, and passes on to the function. So I'm taking all the calls that I get from any endpoint. I run the decrypt function here. So if you see decryption, I would just base 64 decode these messages out and return them back. So one thing that you have seen here is I am processing everything in batch. I am not taking one request for one message. So this is much more optimized and I can handle it. So, and considering warehouses, you get thousands, I'd say millions of rows at a time to process. So having them in batches makes your processing so much faster and more cost effective because you don't need to scale out a lot. So now that we have this function, what a SQL would look like is this. I'm selecting from my customer data set table, joining with my messages. Actually, I should have the inner join, but let's stay with it. Let's join with messages. What I'm getting here is my customer ID. From the customer table, I'm getting the phone number. It's encrypted. We never decrypted it, right? It's just encrypted here. I pick the message dot message ID and message dot message body. I'm getting the message ID, the full message, and timestamp, and everything is still encrypted. I haven't decrypted anything yet. And what I'm doing is using the decryption function that we created as an external connection with Cloud Function and use that to decrypt the phone number and the message body, and then just use that in memory to join. And that's it. And never see the decrypted value. It's never persisted. One, so there's two things. One, when BigQuery offloads the request, it doesn't know the decryption key or whatever, right? So there's no way that BigQuery would have that value decrypted. Now, when you pass to your Cloud Function, it handles the request and returns back only the requested information to you. And Cloud Functions are ephemeral, so it never stays there. Cloud Function and Cloud Run, the two ways that we can use remote functions, they're ephemeral. And unless you explicitly set a storage for your decryption or you print it out on your logs, there's no way to retrieve those decrypted values back. And that makes it super secure, doesn't it? Because in the entire life cycle, we never surface the decrypted values, but we're still able to join and make write any complex queries that we like. And this is what we'll get back. And again, sorry, it should be inner join, not left join, because there's two customers. If you remember, it should just return one customer with a left join. And if you go back and check these values out, only customer ID 1234 should be returned back because that was the only customer who was contacted with a message. And that's what we got. And there decrypted data here. We still have everything encrypted and still we achieved what we wanted. How cool is that? Okay, so as we talk about the benefits, we still need to consider how do we design that entire thing. And as I mentioned in the start, there are no silver bullets. All design, all solution have something that can go wrong and will go wrong in most cases. So we need to consider all of that when designing a solution with remote functions because we're offloading our data out into a compute. One, simplest one to solve is should I use Cloud Run or Cloud Function? That's a simple one. If you have a process that can take more than 10 minutes, Cloud Run, because Cloud Functions Gen 1 did not support uh, run times of more than 10 minutes. Cloud Run, you get a much more longer processing time, but then you need to build your Docker container, you need to write the entire package and then publish it to Cloud Run. But then that gives you much more control over what the container is spin up. Whoops. The next one is cold start. Has anyone heard of cold starts before? I see one hand, two hands. That's it. Okay. So with most serverless processing systems, as we're talking here with Cloud Runs or Cloud Functions, Amazon Lambda, or anything that is serverless, usually has a not usually has a cold start. And what I mean by cold start is because your vendor, your provider needs to spin off compute for your request, it takes a few seconds for that compute to come up before it starts processing anything. So in this case, let's say we have thousands of requests coming in together, and because they can scale down to zero, there's no compute to actually handle your request. So as soon as your requests come through, your compute would start and then take a few seconds and then start processing your requests. And then once the requests are processed, it would go back down to zero. So it causes a latency there. In most analytical use cases, you don't need to worry about that cold start problem. A few seconds doesn't kill anyone in analytical use case with warehouses. But if you have some requirements that it needs to be spot on, it needs to be on all the time, you could set minimum required instances. So you could just have one instance up and running all the time that can start handling requests as they come in, and it would scale to 2, 3, 4, and so on based on the number of requests it sees. And that's so much more quicker. But that's just a hacky way because, again, you pay for that entire compute instance that's running all the time. The other way to do is minimize your the code, keep imports as low as you can, keep it slim, and make sure that your functions are the functions return the same result with the same input. So if with the timeout, that's fine. You can run the request again, and it would process the same way without actually causing any problems. Because these are serverless, you can have all of those problems. Keep your functions as well as you can. The other thing that you need to consider is scaling. Because these services can scale to thousands and thousands of nodes, you're going to pay a lot. So you need to limit scaling. But because you want to balance speed and cost, you need to think about how would you batch your input and pass it on to your compute. If you have a batch size of 1, Cloud Function or Cloud Run would need to create one instance for each and every request. If your batch size is 10,000, so you don't have massive data, because in this case, you just pass one column at a time, and that column is just some string values, nothing massive. You could pass on 10,000 tens and thousands of requests to Cloud Function or Cloud Run to process in parallel. And that would be so much quicker and cheaper because you're not spinning up instances for each request. And batch size and scaling go together because now you can control how much you can go up in scale and what the batch size is based on your use case. Pre-filtering your data, that's the most important one. In this case, what if I just wanted to get information of customers in 2023, but this case you just see one, but let's say you have a million records from 21 to 25, all of that, but you just wanted to see information for 2023. In this case, because you haven't pre-filtered your data, BigQuery would pass the entire records from 2021 to 2025. All of them would be used for your join processing, all of that, and that would use up a lot of compute. So the better approach is just to pre-filter your data here and then pass it on to the decryption function. And that would save a lot of cost. It would speed up your performance because that's what you want. You just want to look at a specific period of data, not the entire history. In some cases, you would, and then you would handle it that way. A lot of people think that was silly, but people still forget pre-filtering data, and that costs. Finally, security. Uh, Given that entire process that we walked around security, sensitive data, PII, we need to take care of security, right? So one, VPCs. Make sure that everything is within your perimeter. But as I mentioned, both of these services are serverless, so there's no static IP that you can put around your VPC. Google offers something called VPC SC, which is called VPC Service Control. It creates a perimeter around your serverless resources, so no one can maliciously use your servers. There are other ways. A simple one is in your functions, don't log your input and output. What if I just print the call here and print the return value? The entire purpose of not surfacing the decrypted values would be gone because you would be logging every single thing that comes in here. So your encrypted value and your decrypted value all on your logs. So silly things sometimes, but you need to consider all of that when designing a solution with remote functions. Demo time. And let's hope that the demo gods are with me. But to get started, I've already deployed everything and tested out before our call. So hopefully things work well. As discussed, there's a remote function that I've created on Cloud Run, and it runs Python. Uh, the logic here, I'll zoom in a bit, and it's the same as what you saw on the slides, but oops, it's as simple as this. It decrypts a base 64 packet, picks up all the requests that it gets in a loop. You can, in this case, it's just a loop decrypted one at a time. You could run so much more with parallel processing, lambdas, and all of that. In this case, I just did one at a time just for the sake of it. So what this would do is everything that it gets in, it would process it. And the same example that I talked about before, I printed the call just so that you can see it, but in production, never do that. So I've just uh, pushed all the calls here, and it would return whatever it gets in, decrypt, and return it back to BigQuery. Coming back here, what you can see is I've created an external connection, and that connection is just a remote function connection that can that also supports remote functions. You can connect it to Vertex AI, Big Lake with GCS and whatnot, and it's a generic cloud external connection. So there's nothing connected to it. There's nothing configured. It's just a gateway that I've defined BigQuery can use. And then I've created a routine, just like any UDS and routines you have on your warehouses. I've created a routine, but this is a remote function. When we say remote function, it says there is a function endpoint. It's an HTTP endpoint that I can connect when I say I query. So when you say call big base 64D function, it would actually send out the requests here using this connection, which I showed just a minute back, and give you results back. And show you an example. I've created the same exact simple scenario. I have a customer ID, a base 64 decrypted phone number, um, secondary customer, a base 64 encrypted phone number, a message, the message body in JSON, and I've just run the same exact query. It's selected from customer, left join messages. Now this time, instead of calling a normal UDF in your warehouse, I'm just calling a fully registered, uh, remote functions. And in this case, I'm saying in this project, I created one for this. In the remote functions dataset, use this UDF, pass on the phone number, pass it as string. Same thing for the message body. I pass it as JSON, get the phone number, and then compare, does the match. And I'll run this now and just have a look. It started the request. There was 0 cloud functions. It took 7 seconds to process that entire thing. So my request turned on a cloud function on the backend. The function returned the request and then shut down again. Maybe it might not have shut down yet. It takes a few minutes after your requests go to 0 to shut down. But you see, I get the same results. I got that this customer got message And yeah, this customer didn't. But there's no information that is decrypted here. It's still encrypted. Again, as I mentioned, this is just simple base64. I could just have gotten away with calling the native BigQuery base64 function, but for the sake of it, I've created a remote function to show you that you can achieve the same thing with much more complex decryption algorithms, which wouldn't be supported on your warehouses most often. If it was GPG, if it was a complex RSA, wouldn't be supported here. And you can save your keys on your cloud functions. So cloud functions, you could mount keys, and with those keys, they stay in your secrets manager. No one can have access to it except for your cloud functions, and it's a completely secure environment. Hopefully, this demo made sense. But remote functions are not just for this. There are some other use cases as well. First one, AI and ML. Finally, I'm talking about AI. Everyone's excited. Um, you could use unstructured data on BigQuery and then have a remote function that can process unstructured data because you can use Python, Java, JavaScript, any kind of library to do all of this processing. You could call self-hosted AI models from BigQuery. So what if you want a small model which is under your control? Maybe you want to use a smaller version of Gemma 3, you want a small version of Llama, you host it on Cloud Functions, probably Cloud Run, not Cloud Functions, produce Cloud Run, and then you can call those small models from BigQuery just using SQL. How easy is that? Data protection, as I mentioned, encryption. You could have complex encryption and decryption logic sitting in Cloud Functions. Log processing. BigQuery supports dumping your logs into BigQuery, so you can do so much more with BigQuery, and then you can have complex compute going on behind the scenes. You can have external API access now on your warehouse. So if you wanted some real-time information, some custom data sources within your org, without actually having to run through an entire ingestion process, you could just call a cloud function that hits an endpoint, internal or external, fetches that data, and then just use that in your queries. How simple would that make everyone's life? And finally, enriching traditional ETLs. Anyone who's worked in large corporates know there's still so many legacy ETL softwares that people use, even with modern warehouses, and they do have limiting features. So what we could do is create UDFs on BigQuery which can do complex computations, and you can call them with SQL. And traditional ETLs do support SQL. So writing a SQL logic there makes everyone's life so much simple. And just to summarize everything up, remote functions and other options for BigQuery remote functions offload your data processing outside of your SQL engine. You can integrate non-logic, I showed you, with SQL. So now you can actually run non-SQL, Pythonic, JavaScript, Java logic by just calling them with plain SQL. And if used properly, and I'm going to emphasize on it, if used properly, they can enable so much complex use cases, so low cost. Because everything is serverless in this scenario, you're not going to pay for running VMs or Kubernetes engine somewhere, and you're not going to pay for all of that. You just pay for the time you use the compute, and that's it. There is a GitHub repo here where I have terraformed this entire process. So you can deploy cloud functions, remote functions, connections. I am everything packaged in this GitHub repo. Give it a shot. You can deploy the same thing that I showed you on BigQuery in 10 minutes. And here's my LinkedIn. If someone wants to connect and ask any questions, let me know. And I'm open to any questions now.
Any questions? Thanks, Yash. Eric, did you have a question?
Yeah, he kind of explained it along the way, but so I guess I guess my questions around the UFTs. You can do most things within BigQuery without involving taking it out. So I was hunting for why I would take it out, other than the example we use, I guess, which is keeping your encryption keys separate.
Mhm.
Is that the main reason you do? I know you detail some of the obvious.
Yeah. That's a fantastic question, because BigQuery natively supports JavaScript and JavaScript only. Um, you could do a lot of things with JavaScript, but then there's limiting factors as well with UDFs, is that you cannot import complex libraries with UDFs. So let's say if you wanted to have a API request sent out from your JavaScript function, you wouldn't be able to do that. You can't import libraries in UDFs. There's just a small set of libraries that you can import. So if you want to have complex logic, you would have to offload it into a cloud function or a cloud run. The other one is another example that I talked about is if you have your AI model hosted on Cloud Run, you can now access it from BigQuery using a UDF, but not a UDF, sorry, a remote function. You can't do that with UDF. Does that answer the question?
Yeah, yeah.
Yeah, yes, yeah.